Hello, YouTube viewers. Namaskar, Pranam. Welcome to once again Dr. Rajesh Verma's YouTube channel. And in this particular video, I'll be talking about graphical representation of data. The pertinent question that arises during the preparation of that particular topic is that why we need to represent the data in the graphical form. If you want to know the just one simple answer in one liner, that is to present the data in visual form. You know, the visual form is more attractive and more eye-catching. So to attract the attention and eye of the general public or the researcher or anyone interested to study the data, we need to represent the data in the graphical form. So before we start, let us define what is that. What is graphical representation? If you want to someone else to say, so what is the definition of the graphical representation of data? The technique of representing this course by various type of graphs such as frequency polygon, histogram, pie chart, ogive, that is the cumulative percentage of frequency, curve, etc. etc. These are the various technique through which we represent our data in these forms. So that is the all you call as a simple definition of the graphical representation. Now let us go for some introductory part. You know, the ungrouped data that is in unrow form has been grouped by converting into frequency distribution. First, the original data is converted into the frequency distribution. For that, before that, that is to be grouped. Why that is grouping required? Because to use the very statistical technique, advanced statistical technique, we need to prepare the data into groups or classified. So for researcher, it becomes difficult to analyze it in totality, because if the data is not grouped, it becomes very, very difficult to analyze it completely and to bring or conclude or draw the inferences from that raw data. For that, data has to be first grouped into various forms and converted into a transformed into frequency distribution. Along with that, the numbers and tables have been known to evoke fear, anxiety, boredom, and misunderstanding. This is the funny statement made by but it's a true statement. The numbers, the tables, and various you say data forms that create a sense of fear or a sense of anxiety or repulsiveness in an individual. They do not, people generally have a tendency to shy away from these things. So to prevent that too, and to ensure that the people understand the tables, the data properly, for that we need to and to challenge these issues, the numerical data is presented through the pictures and graphs, various types of. So this is a very funny thing, that we are repulsive of the tables, repulsive of the data, and to overcome that we use the graphical forms or the various graphs and figures for representing our data. These pictures and graphs, commonly known as the visual representation, that catch the eye and hold the attention of the viewer, that helps in making quicker sense of the out of numbers. Means what numbers wants to say. From that, it becomes very difficult for us to infer or conclude from that numbers. So if the numbers are represented in the graphical form, then it becomes little bit and easier, and it catches our eyes. As you know, as Garrett puts it, the research worker also utilizes the attention getting power of visual presentation. So this is the one liner why we represent our data in the graphical form is it has the eye catching ability, that is the visual presentation, and at the same time seeks to translate numerical facts, often abstract and difficult of the interpretation, into some concrete and understandable form. The visual representation makes the data understandable for even those individuals who are not very much familiar with the data or statistics. So this is a very important one. The graphical representation is known to improve the readability of the findings what are the findings, what are the conclusions or the inferences that can be easily understood or read by the individuals who are not very much familiar with the technicalities of the statistics. One more very much example, that is advertisers. They frequently use this graphical representation. They do not put data in front of you on your TV screens. What they do is they convert the data into graphical form and then they present. Suppose an individual selling some shampoo or some FMCG goods, they will tell that in the last year we sell this much figures, the graph was this much, but today nowadays, because we added an extra feature in our soap, or so that due to that our figures has gone up, and that can be shown by the your graph. So it's a very important one. Then, my dear friends, will be what are the graphical representation methods. So we are discussing each. Suppose the first one is the data can be represented graphically by following 5 methods. There are at least 5 methods through which we represent the data. First one is the frequency polygon. You can see once again, it is a frequency polygon right side that this figure gets activated. You can see here, this is the frequency polygon. Do not worry, I'll be explaining each in little bit detail in the subsequent slides. Then comes the second one, the histogram. So this is the histogram, through which also we represent our data. The third one is the bar graph. So this is the bar graph. I am going to explain you the difference between the histogram and the bar graph. It's a very thin difference. Then the fourth technique or the fourth method through which we represent our data is the cumulative frequency graph. So this is also a very important one, and it's tell and various facts about the data. And finally, one is the cumulative percentage frequency curve, or we generally known as the ogive. So dear friend, these are the 5 methods: frequency polygon, histogram, bar graph, cumulative frequency graph, and cumulative frequency percentage frequency curve, or the ogive. Now we'll be discussing each method in a little bit of detail. So you know these are the 5 methods by which we represent our data through graphs and various pictures. Before that, before we start representing our data through visual images or graphs, we must understand some general principles that are exclusively suggested by the Garrett. The very book which is in front of you. First principle is the graphs are plotted with reference to two lines, commonly known as coordinate axis. The vertical line is known as the y-axis and the horizontal line known as the x-axis. The second principle is these coordinates, that is, you know the coordinates, that is, these two coordinates perpendicularly intersect each other at a point called O. That point is also known as the 0 point or the point of reference. This means the point at which both the coordinates intersect each other has 3 names, that is origin or point of reference or the 0 point. So third principle, the distance measured to the right of an x-axis is positive one and left it is negative one. So from where right? You know the reference point O. From the O, if we measure the difference, this is the O. From here, if we measure the distance this side, then on the x-axis it will be positive one. From this side, it's the left side, it will be the negative one. And above, if we use the distance here, that is the positive one on the y-axis, and here it is a negative one on the y-axis. So this is the third principle. One more, both the lines when perpendicularly intersect each other forms 4 quadrants as shown in the figure. So this is a very important one. You must understand the basic concept here. So when these lines intersect each other, they form 4 quadrants. The quadrant 1, the data that falls in the quadrant 1 should have, or the data that falls in the quadrant will be both on the x-axis and the y-axis will be positive one. In the quadrant 2, you can see in the adjacent figure, the data on the, you can tell me, y-axis it will be positive one, and on the x-axis it will be negative one. In the third quadrant, both x as well as y will have a negative data, and in the fourth quadrant, x will have a positive data whereas y have a negative data. So this is a very, very important one. You must understand that first both positive, one negative positive, both negative, and the positive negative. So this is a very important. Now, next principle. While writing the coordinates in numeral forms, it is universal principle that first number denotes the x coordinate and the second number denotes the y coordinate. Suppose there is a one numeral form, some data is written, that is 4 3. 4 indicates the coordinate or the number for the x-axis, and 3 denotes the y-axis. So it is a universal principle. First number always denotes the x coordinate and second y coordinate. And the next principle is the x is called the abscissa and y-axis is called the ordinate. So these are different names. The vertical line is known as the ordinate and the horizontal line is known as the abscissa. So dear friends, these are the few principles we use for the graphic. Before we use the graphical representation data, we must know that. Now there is in front of you one table I have just shown to you. This table has some data, the group data, and I am telling you this is hypothetical data. The data is arranged in first in the class intervals, in the second columns it is the midpoints, third column it's a tally, fourth frequency, fifth one the cumulative frequency, and the next and the last sixth column is the cumulative frequency percentage. Getting my point? So let us start with the graphical representation of the data. The first method I told you, discussed you, is the frequency polygon. In short form, it is also known as the FP. Polygon means a plane figure with 3 or more sides and angles. A frequency polygon is formed using data from data table 1.1 that is in front of you. Poly means more, gon means sides, means more sides, 3 or more sides. If you know, if there is a plane figure that have 3 sides, that is not a triangle, but the figure that is more than 3 sides we call it a polygon. It can have any number of sides, but that should be more than 3. Getting my point? While drawing the frequency polygon at the abscissa, abscissa, you know, x axis or the horizontal line, exact lower limits or the midpoints of interval can be used. On the ordinate, that is y-axis or the vertical line, respective frequencies can be plotted. Then these points should be joined with short lines to make it polygon. Before that, to make it more clear, I will show you the previous figure once again. See, on the x-axis, these either the class intervals or the midpoints are to be plotted. Whereas on the y-axis, these frequencies are plotted to make the frequency polygon. So that I want to say, which I discussed you the frequency polygon. Now let us move to the next method, that is the histogram. The histogram is also known as the running column graph. Running column graph means there is no difference, no gap between two columns. That is running column graph. In contrast to frequency polygon, where scores are represented by midpoints of class intervals, in histogram, these scores are assumed to be spread uniformly over the entire interval. So, in histogram, each frequency is represented by a rectangle, the base of which is the length of interval or the size of the class interval, and height is number of scores. So this is a very, very important one. We have represented the midpoints here on the x-axis, and on y-axis we have the respective scores, respective frequencies. So my dear friends, the size or the width of that histogram or that particular rectangle is represented by the entire interval, size of the class interval. If my size of class interval is 3, this means this width of this particular rectangle represents the width of the class interval. Whereas the height or the length of this class, that is rectangle represents the total frequency or the scores in that particular class interval. This is the histogram. It's a very simple one to plot. Then the third one is the bar graph. The bar graph is similar to histogram, but have a small difference. Could you notice the difference between the histogram and the bar graph? If you do not, I will let you know. I'll explain you. I'll show the previous slide too. Bar graphs are typically used to display the frequency or percentage distribution of discrete variables. You know what is the discrete variables? Variables that can take a finite number. That is very good. That someone want to measure the IQ of some individual. That IQ can take a finite number. That is, you say it's 120, 130. Such type of discrete variables are represented through the bar graphs. But if you want to represent the intelligence, I am not talking about the IQ, intelligence. In that case, that is we represent that by through histograms, because they do not have a continuity. Due to the lack of continuity, we represent the discrete variables through the bar graphs. It means there is a space found between the bars in the bar graph. You can see the white space between these bars. Histograms are used to display the continuous variables having no space between the bars or the rectangles. You can see just the previous slide once again. In this histogram, you will find there is no difference or no space between these rectangles. But whereas in the bar graph, you will find there is a space or gap given between these blue rectangles. So this is the very finite and very subtle difference between histogram and bar graph. So in the last slide, I'll let you know where to use bar graph and where to use the histogram. So next method to represent data graphically is the cumulative frequency graph, commonly known as the CFG. You know the cumulative frequency? Cumulative frequency means adding the frequency from lowest one to adding frequency of the each class interval and finally reaching to the top. It contains both polygon and histogram. It's a very interesting one. CFG contains both polygon and histogram. The CFG is plotted in the similar lines as FP, as we have plotted the frequency polygon, where the class intervals or the midpoints are shown on the x-axis and the cumulative frequencies are shown on the y-axis or the ordinates. Getting my point? And x-axis is also known as the abscissa. So you know, oh, it's very good. You know this. You could remember that. The only difference between the frequency polygon and the cumulative frequency graph is that in place of frequencies, the cumulative frequencies are plotted on the x-axis. This is the only difference. The CF, that is the cumulative frequency corresponding to any class interval, is the number of cases within that interval plus all those in the intervals shown on the lower scale. That is the point clear to you? See, cumulative frequency means we are adding frequencies when we're reaching the next class interval. So subsequently, we keep on adding the frequencies, and that indicates the cumulative frequency of each class interval. So this was the cumulative frequency graph, how it can be represented. The next one and the last method for the graphical data is the cumulative percentage frequency curve, or it is commonly known as the OSI. The cumulative percentage frequency is plotted on the same line as the CFG. I need not to explain once again. Here the only difference is on the y-axis we plot the cumulative percentage of frequency. So I'll show you the previous table where I have calculated the cumulative frequencies, percentage frequency. So difference between is that the cumulative frequencies are the total frequencies of the class interval plus below all the class intervals, whereas the frequent percentage is the percentage of the particular, that base is 100. So we'll move to that particular table once again, and that the table is this one. So this is the difference. This is the cumulative frequency, and this is cumulative frequency percentage. So in the last class interval, that is 53 to 56, our cumulative frequency is 35, whereas the percentage is 100. You can see the difference. So in the cumulative frequency graph on the y-axis, we represent these cumulative frequencies. Whereas on the ogive, where cumulative frequency percentage graph is plotted, in that case we represent these frequencies on the y-axis. So dear friends, these are all our methods. So we'll be now only last slide we'll be discussing where to use which method. That is, where to use the bar graphs, where to use the histograms, where to use the frequency graph, where to use the cumulative percentage curve or the ogive. So frequency polygon means it is used to visualize the shape of distribution of all types of variables, whether a variable is either discrete or continuous. To understand the shape of the distribution, the collected data, that is the distribution, what the distribution shows to us, for that we use the frequency polygon. Histogram preferably for continuous variable. Whenever we measure, collect data on the continuous variables, for that it is preferred to use the histogram. For bar graph is for discrete variables, variables that have fixed value and they lack the continuity. In that case, we want to represent them through the graphical representation. For that, it is preferable to use the bar graphs. Then cumulative frequency graph to visualize the general trend of distribution for all types of variables. Here there is no specification. All time either the variables are discrete or the continuous, and to see the general trend, how that data generally moves towards, or the orientation of the data. For that we use the cumulative frequency graph. And finally, where we use the cumulative percentage graph or the ogive to visualize the trend in percentage terms. If you want to understand the trend of the data or the distribution in the percentage terms, for that we use the cumulative frequency and percentage frequency graphs. So dear friends, these are all my references. You can cross check them. And before that, I'll just will recap that. We discussed the meaning, definition of graphical representation of data. We discussed the definition, meaning, then different types of methods of graphical representation, 5 methods. Before that, we discussed the various general principles, 6 general principles we use before we using the start using the graphical representation data. And finally, we discussed where to use which method, where to use the frequency polygon, where to use the histogram, where to use bar graph, where to use the your cumulative frequency graph, and where to use the cumulative percentage frequency graph. So you must refer these books. That is 2 books important, Guilford and Garrett, which is in front of you. In the stack of this figure, the first one is the the Guilford book, and the second yellow one is the Garrett book. These are very basic books for the understanding all these things. So to have deeper understanding, we must go through these books. My dear friends, we'll be meeting very shortly with the next video, and the next discussion will be measures of central tendency. In this, we'll be discussing various measures such as mean, median and mode. Now, dear friends, thank you for watching this video, and if you like this video, share with others, subscribe my channel, and if you dislike it or you have to say something, you just write to me. You can write me through comment box, or you can directly email me at my email varmasujit@yahoo.com. Once again, thank you friends for having your patience, keeping your attention to me and watching this video.